The last type of inequality that we're going to look at is the quadratic inequality. It's quadratic because it has an x squared term in it. Solving these is a little more involved because we can't simply just get the variable isolated on one side of the equation, as it shows up twice. We have x squared and we have negative 6x. So just like before, we need to actually factor this inequality. We need to find two numbers that multiply to negative 7 and add to negative 6. Those would be negative 7 and 1. So we factor. But now this inequality is actually comparing these two factors to 0. So we need to figure out, when we take x minus 7, what number would I substitute in for x to make that bracket work out to 0? Well, if I take and I substitute in a 7 for x, it'll make that bracket work out to 0. Same process with the x minus 1. If I substitute in a negative 1 for x, it'll make that bracket work out to 0. Now, for the actual process of solving this, we need to do something called a sign analysis. Signs being positives and negatives. So what I'm going to figure out in this whole process is, where is this inequality positive? Where is it negative? I've already figured out where this inequality is 0. So to do this sign analysis, I need to draw a number line. It's going to have 2 points for the moment, one at negative 1, one at 7. What I know is that if I substitute in a negative 1 or if I substitute in a 7, that inequality is going to work out to 0. But what I need to find is, what is the sign in each of the three regions that I've now created? So I need to pick a number in each of those regions and determine whether or not we work out to a positive, a negative, or a 0. So I'm going to pick negative 3 on the left. Could have picked negative 2. Could have picked negative 2.5. Could have picked negative 55 if I wanted to. I'm going to pick 0 in the middle. 0 just makes the math a little bit easier. And I'm going to pick 8 on the right. Doesn't matter which numbers you pick as long as you pick numbers that fit in all three of those regions. So off to the side, I'm going to do some calculating. I'm going to start with negative 3. I'm going to take that, I'm going to substitute it in to x squared minus 6x minus 7. And from there I'm going to work it out and see if I get a positive or a negative. Negative 3 squared is 9. Negative 6 times negative 3 gives me plus 18. And minus 7 will give me 20. 20 is a positive number, so I know when I plug in a negative 3, or if I were to plug in anything on that side of negative 1, I'll get a positive out as my answer. I need to repeat this process for both 0 and 8. 0 makes the math a little easier. We get negative 7 out, negative 7 being a negative number. So anywhere between negative 1 and 7, this works out to a negative. And once more with 8. Make that 4 look a little nicer. I get a 9 as my answer, 9 being a positive number. Now I need to look at my original inequality and determine exactly what I'm trying to find. Well, if I look at my inequality symbol, I am looking for whether this quadratic is greater than or equal to 0. Greater than 0 meaning positive. If I look back at my number line, I've got two sections where this works out to positive. One on the left, right here, one on the right over here. So when I go to my interval notation, I'm actually going to have two separate answers. My first one on the left goes all the way to the left, goes all the way to negative infinity. Where it stops being positive is at negative 1. Now for the brackets, negative infinity takes care of itself. We can't get there. It's got to be rounded. Negative 1, however, we need to refer back to the original inequality. I want to know whether x squared minus 6x minus 7 is greater than or equal to 0. that or equal to part tells us that -1 is going to have a square bracket. My second region starts at 7. That's where we change from positive to negative. And it goes all the way to the right to infinity. Again, it's an infinity. It's got a rounded bracket. And again, since we have an equal to line included in our original inequality, 7 gets a square bracket. Now, since we have two regions, we have to say that we have two regions. We could put the word "and" in between them, but there's a mathematical symbol for the word "and." It looks kind of like a U without a tail at the end. It's called union. Basically translated means the word "and." So we've just solved this quadratic inequality.